one person waiting, so I told him he will be join us just within a minute.
Sure, take your time. Let me bring up a couple of slides which we are going to discuss today.
Okay.
I will set up an agenda for a couple of discussions from here onwards. I mean, at least the agenda for next 2-3 days, so that you guys have visibility as to what we are going to cover in next 2-3 days. And then we'll keep on doing this for our subsequent sessions. Okay?
Okay.
Great. At any given point in time, feel free to stop me and ask your questions. It is important that this session is kept interactive. This is to get most out of these sessions. We'll wait for other participants to join in.
Okay.
Guys, can we get started now? Do we have everybody with us?
Yeah, I think we can start now. Yeah, there was one guy. He, I don't know. We are not sure whether he will just join us because it's a long time. I don't have any information about him, so we can start.
Okay, so okay, let me ask this Learn Chase team. So team Learn Chase, do you want me to get started or do you want me to wait?
1 minute, sir. I'll check, sir.
Okay. So let's utilize this time when LearnChase teams come back. Guys, would you mind telling me about your technical background so that I have little visibility into your technical skill sets?
Yeah, actually, Mamar, can you? I don't think your voice is reaching us.
I don't think he is speaking either. He's on mute.
Okay, for me, it's show me as he's speaking. Okay, let me start. I think if you have information about the Ganesh, he already gave us some sessions just with the data power. So I already have the some basic understanding of the data power IIB with FairMQ. So for API, I don't even have any background.
Mm-hmm.
And I hope the other guy even memory is the same as me.
And what's your technical background? I mean, you are engineering grad or how it is?
Yeah,
This?
I'm working as an IBM consultant.
Okay, great. So you're already working professional in IBM work. Okay.
Yeah.
And memories also?
Yeah, he's also working as a consultant.
Awesome. Great. And how many years of experience do you guys have in IT?
For me, you can say around 7 years.
Oh, great. Fine. So this will help me orient the discussion. You guys are familiar about web services? By any chance?
Hello?
Hello.
Sorry. Hello?
Yeah. Tell me.
Yeah, Ajit, you can go ahead.
Okay, great. So let us get started. And I'm trying to share my desktop with me. Desktop with you, sorry. And you guys can see it. Okay. Team LearnShares, would you mind giving me the recording permission too?
Hello?
Yeah. Would you mind giving me the recording permission?
Okay, you want your recordings?
Yeah. I would like to on my local laptop. No, it's okay. Fine. You recorded. That's okay.
No. I'm already recording.
Mm-hmm.
If you want, you can go to my website and go through the classes. Or else, if you want directly, I can give it to you.
Okay, great. I'll connect with you. No problem. Fine.
Sorry. In addition to that, for LearnChase, can you just upload those recorded videos? I just want to record then this session.
Sorry, didn't get you.
Yeah, can I able to get a recorded video after the session?
Yeah, sure, but only read access through our website.
So can you just share me the information how to reach out that website?
No, whatever Ajit gives me, the documents or anything, I can share it to you. I can't share any of videos or anything. Sorry.
Okay.
Yeah.
Okay, team. Let's get started then. I think it's time to get started. So I welcome you all in the IBM API Connect course. And as we have discussed, we already have an introduction about it in our last session, which was demo session. So I will not waste any time and will kick start from the very beginning of this course, which starts by answering the question, what do we mean by an API? So there are three things that you guys have to, that you guys must be hearing. The first one is web services. The second one is the API. And the third one are microservices. These three things are floating around us. And we need to understand basically that what are the similarities, differences, and relationship between all three. So let us try to answer this question, that what is an API? An API is essentially a set of web services, but forget about this slide for now. Let's talk about an API from a different perspective. Now that you have started learning the API management, before this, you must have learned some traditional programming languages. Programming languages like C, C++, Java, maybe Perl, Python. You have learned those programming languages. Is that correct, guys? Have you learned one of them?
Yeah, you mean about the REST?
No. Forget about REST, SOAP, API, web services one. Forget about them completely. Let's talk about traditional programming languages like C, C++, Java, JavaScript, or Perl, Python. Have you learned any one of them?
No.
No programming language?
Yeah, just having some basic understanding.
Yes. I'm only talking about, I'm not asking for a very expert knowledge, right?
Yeah.
So, for example, you have learned IIB. So, IIB cannot work if you do not have basic understanding of Java and their ESQL language. Am I right?
Yeah, sure.
Right? So, that's what. Now, while learning these languages, you must have found that there are few things that are built in, and there are few things that you program. For example, if we talk about Java, there are few pre-built contexts which allows you to open a file, read and write a file. Am I right?
That's correct. Yeah, that's correct.
Right. Now, these are called Java APIs, and they are well documented. You can go through the website and you can read more about those Java APIs in order to understand what they take as an input and what they give you as an output. Do you have any visibility into how they perform their duties? For example, you are opening a file on the file system, you are trying to write it, you are trying to read it. But how the read operation works, how the write operation works, do you have any visibility into that?
No, I don't.
No, that's the beautiful part. So these are APIs, and these are APIs in their very primitive sense. The concept of API says, I'm writing a reusable piece of code which has defined input and which can give you defined output, and you don't have to worry about how the implementation of the function has been written. All that you have to care about is you give it the right input and you get the job done. Am I right?
Yeah.
This is API. Now, there is a problem with these APIs. Actually, not a problem, but I would say shortcoming. And the shortcoming of this API is that you have to be a Java programmer in order to use those APIs. For example, Java says this is an API to open a file, read it, and write it. You have to write a Java program to call these APIs. Can you write a C++ program to call these APIs?
Right now, I can never say that because
and it is this is something which could be very difficult to do, if at all not impossible to do, but at least very difficult to do. So you have to be writing a Java program in order to call these APIs and reuse them. But what if we can become programming language independent? If we can write a function that does not require you to be a Java programmer in order to call those APIs, that would be excellent. And that is the concept of what we call web APIs. Well, when I say web APIs, I'm not referring to a very specific product from Microsoft, but I'm talking about any APIs that is invocable over HTTP and HTTPS protocol by using simple browsers. Now, initially, the concept got implemented into what we call web services. So, web services, see the term web services. Services means reusable piece of code. Web means the one that can be invoked using popular web protocols. And what is the web protocol? HTTP and HTTPS are web protocols. That is why they are called web services. Now, when web services were created, they were become hugely popular. In fact, there are two flavors of web service. One is called SOAP-based web service, and another is called REST-based web services. SOAP is the older concept that is still valid and is still used in practice. RESTful are newer concept. They relax the constraint to some extent so that the web services can more easily be called and their data can more easily be consumed. Essentially, the idea of web services is exposing reusable piece of code in such a way that they can be invoked over HTTP and HTTPS protocols. Now, these web services, they have many operations inside them. These operations are actual services which allows you to perform a task without knowing the implementation. Now, people have evolved a little, and what they have done is they have made these web services more lightweight. For example, I give you an example, and that will make things much more clearer than what we are talking about here. So hold on for a second. Take an example. Let us say that we are talking about a we are talking about a web service. As I told you, web services comes in two different flavors, SOAP and REST. A SOAP service is usually described by a WSDL. I'm loading a WSDL into a testing tool called SOAP UI. Okay, this WSDL seems to be inaccessible, no worries. No, it's not loading. Okay, it looks like to be inaccessible, no worries. When you load a SOAP service, you will see that loading it results in creation of this structure. Now focus on the first one. You can see that these are two operations over here. These two operations are what we know as a service. Now, the problem is that we have to create this big structure in order to just see these operations. These are called operations. And the actual task of the service is done by these operations. What if we can get rid of this complexity and we can have just these operations there and we can call them and we can use them without any much needed complexity? That is the concept of RESTful services, and that is what we call APIs. So APIs are all essentially web services, but they are lightweight. Lightweight in a sense that in order to package a pen, you are not using the carton that is used to pack a fridge. Think of it. It's a very simple thing. Can you see this? You are sending this data to the server. Server may give you a response. But the sheer size of the rest of the elements far exceeds the size of the data that you want to send to the backend. You can count on characters, man. 2, 4, 6, 8, and then decimal places. So hardly it is 15 character, I would say. But the rest of the details, you are basically packaging a pen in a carton that is meant for packaging a fridge. Do you ever do that? No, you don't do that. But with SOAP-based services, we do that. The idea is to less burden this. The idea is to remove the rest of the part of what use this is. Just get rid of them, and you have a lighter weight web service where you can pass on this input as part of the URL. The input goes to the backend web service. It gives you the response, and the response is displayed here. This is what we mean by making it lightweight. And if you make it such a lightweight service, then perhaps either you have created a flavor of web service, which we call RESTful service, or you have created what we call APIs. APIs in their definition are reusable pieces of code that can be invoked over HTTP and HTTPS protocol. Well, that is the same definition of web service that I gave you. So what's the definition? Well, there is no real difference between the two. But at the implementation level, at the very ground level, APIs are only usable if they are lightweight. If they are not lightweight, they are not usable. Nobody uses them. So it is safe to say that API and web services are same thing. However, APIs should be more lighter weight and less complex than what a SOAP service can be. But at the very technical level, I would say APIs and web services are exactly the same things. There is no difference at all between them. The recent trend is towards building APIs that can be called easily and that can be as lighter weight as possible. That's why the definition says an API is a set of functions that provide some business or technical capability, and that can be called by applications by using a defined protocol. An API is composed of operations which are offered in one of the following style, either RESTful or SOAP. The footnote simply says that some people mistakenly believe that RESTful APIs cannot accept XML as the data item, or they cannot produce XML. They can only deal with JSON. That's a wrong concept. A REST API can understand XML data as well as non-XML data like JSON, etc. But at their most technical level, APIs are a bunch of web services. Now, what is the concept of what we call microservices, if we say, and how it relates to the web services? So the concept of microservices simply says that, let us say that you have let us say that you have this service, right? You have this web service. Now, this web service has two operations, here and here. What if you expose these two operations not as an operation, but as a service themselves? Then what we get is, we call it microservices. There is very fine difference between a web service and a microservice. A microservice is also a web service. But traditionally speaking, when you deal with web services, you get several operations like get GeoIP, get GeoIP context, and then you work with them. But when you deal with microservices, you do not get these several operations. Each microservice is an operation in themselves. Now, when it comes to implementing such a microservice, the difference starts showing through. In what sense? In a sense that these microservices, they are developed more rapidly than a web service. And there is a different method of deploying them than the web service. That is why the term microservices and their meaning is more understood by the team who uses Java or Swift or similar other programming language to develop these microservices and then deploy it to them. Sitting on the IBM API management layer, for you, it is hard to differentiate between a web service and a microservice. But conceptually and concept-wise, I told you that microservices means you have exposed each of these operations as a service in themselves. Now, if you relate this concept back to the concept of RESTful services or RESTful APIs, you would say that in RESTful APIs too, we do the same. And I agree with you. In RESTful APIs, you do the same. So, when we talk about microservices, they ultimately will boil down to what we call RESTful APIs. In RESTful APIs too, we expose each of these operations as an individual service. And hence, we essentially develop what we call microservices. The framework to develop RESTful APIs and microservices could differ, but the idea is that the concept of microservices are more near to the concept of RESTful API. And now here is the evolution path. Initially, when the concept of services and when the concept of APIs were developed, they took the shape of Java API, C++ API, etc. Then the evolution came in and people exposed these services. People exposed these reusable piece of code as SOAP web service. You have a SOAP web service right here. Then people realized that they are packaging a pen in the carton of meant for a fridge. So they said, let's simplify it. And the evolution, by evolving them, they took the next step and they created RESTful web services. Then they deployed these RESTful web services and there was a huge success. Then the evolution came a little further and we have further, I would say, we have further broken down the services and we have got the concept of what we call microservices, which is also called APIs. Microservices and APIs are synonym terms. Now, these microservices are lighter weight and there is a full framework for their development in the backend, and they can be independently called. They can be composed with each other in an independent manner, and they can be reused in whatever format that you can think of. So this is the evolution path of these services. Any questions so far, guys?
The question I have is, what is the reason behind to expose those operations as a microservice?
Simplicity. the only objective is to get the process simple. If you want to call, for example, if you want to call this get GeoIP operation, which takes one single thing as an output, you have to construct this entire SOAP message, right?
Yes.
You have to construct, and then you need to send it. When you say you need to send it, you are making a post call to the backend. Get it?
Yeah.
Now this service is not functional, so I don't know if it will give you the response or not, but it says simply, it's not giving you the response. But anyways, so you need to, but do you think that just to pass the single input, we should construct this big message? It is like you want to send a pen to your friend, but you are packaging it in a carton meant for packaging a fridge. Do you usually do that?
No.
I mean, this looks to be a foolish idea, but we are doing it here, right? You can say this. So they said, let's simplify it. This is the server location. Sorry, this is the server location.
So as a URI, we can include the
yes. So
the
it
value
says
of
simply,
okay.
one simple way could be simply saying I is equal to 12.56.23.45, and they say you should be able to put this entire URL in the web browser, hit the enter button, and you get the response. Isn't that more convenient than loading the WSDL first into this special tool called SOAP UI, and then constructing this SOAP message and then hitting it and then getting the response?
Yeah, you are right. But here, since we have the only one element here, it's easy just to make it simple. But what if we have, more than one value here? For example, we have only the IP address here.
Yes. Let's say we have 10 values here.
Yeah.
If the input structure is very complex, it makes sense to use SOAP messages. But the input for majority of the operations, I would say, the input structure is simple, and so is the output structure. The essential idea, the essential design idea behind creating microservices or RESTful services for that matter is that you have smaller but reusable piece of code. These smaller pieces of code can be combined to create bigger functionality. You are free to add 10 inputs over here, which means that essentially your service is doing some very complicated task. Otherwise, who gives it 10 inputs? Think about the good API design in the past. Have you dealt with any Java function, any Java API that takes 10 things as an input?
I'm not sure.
Ever? No, nothing. No function takes 10 things as an input. If it is, then it must be doing something awfully complex task. So the idea, and you cannot even remember the signature of that function. Am I right?
Yeah.
Right? So you usually remember the APIs whose signature contains 2 or 3 inputs. Even 3 inputs is something which is considered harsher. So you have just 2 and 3 inputs. The logic I'm bringing in, the argument I'm bringing in is why to pass in such a huge envelope, in such a huge package. Just pass it on as part of the URL. You anyways have to send it to the backend, right? And you're sending it as a key value pair. What's the harm in doing that?
Yeah, you are correct, but it might depend from company to company. Some companies might have so many, request parameters in their payload. So if they have, lots of elements or fields on the request payload, it's impossible just to put on the URI part as a expert or something expression.
Yes, and I'm not. What you said is right, and I'm not adamant to sending all the parameters as part of the URL. The essential idea that I'm bringing in here is that you want to call a service, you call the service, but do not send unnecessary part to the backend.
Oh.
These are unnecessary parts.
Okay.
What value they bring into you? Tell me.
Yeah, you're correct. Nothing.
Right. So there, whatever is not bringing you value, just remove them.
Okay.
That's one. Second is I'm not stringent to the idea that a service needs to have only 1 or 2 or 3 parameters. The practical matter of fact is that in your companies or in companies where you work for, they could have 10, 12 or hundreds of parameters out there, right?
Yeah, right.
You yourself will agree that that is not a good service design. Good or bad, they exist there, and things may not be in your control all the time. But the idea I'm bringing in here is that if you deal with XML data, perhaps you are stressing your system a lot. Why? XML inherently is complex to deal with when it comes to systems. So why not little be open? And why not use the JSON as a format in order to exchange information? If you use JSON as a format to exchange information, you have already stepped into the world of RESTful services and APIs. So,
sorry, if we include this value, the IP address value on the URI part, that means we don't have nothing on the request payload. It will be null.
Yes, it will be done.
Oh, okay.
The philosophy of the REST is make it as simple as you can. Got it?
Yeah. So the request the request section is going to be null. Yeah. Right.
Yes. The body is going to be empty.
Oh. Okay. That's clear.
Okay. So now that we have spent some time understanding this, what we are going to learn as part of IBM API management? In IBM API management, we are going to learn the fact that if my client has traditionally developed SOAP services, we should be able to expose each of these operations as an individual API. Well, you may come back to me and say, these web services are working fine. I got your argument that you want to make them lighter weight. That's fine. But just to make them lighter weight, do I go ahead and purchase such a huge product as an IBM API management? No company can afford to do that. So what is the additional benefit that you are getting? The additional benefit that you are getting is that you can market your APIs like commodities. This is the same argument as think of it from this perspective. You have opened a business of restaurant, and please hear me out. You have opened a business of restaurant, right? Now you say that in restaurant, the essential idea is to cook the food. So I will only create, or I will only spend money on creating the kitchen. Will that work? Tell me.
Sorry, come again, please.
So my question is that suppose you have started the business of a restaurant. Okay?
Yeah.
And you think that the main purpose of the restaurant is to prepare good food and then send it and then sell it to people. Now, you said if this is the essential idea, why not spend my 100% money on kitchen? So you created a huge kitchen where things could be prepared and so on. Do you think this is your restaurant and your business is going to take off?
I don't think if I spend all 100% on there.
So what is missing here?
I think in order to say a restaurant, kitchen by itself is not enough, I think. I don't know whether I get your point or not.
So yeah, you got it. So what is missing here is the front part of your shop where customers can come in, place the order, grab their meal, can maybe sit and enjoy and things like that. Am I right?
Yeah. Sure.
Physical or virtual, you need a way where your customers could see your products, they could see their descriptions, they could order them, maybe for a good experience, they could see them preparing, and then they get them, maybe enjoy their food. Different part of your shop is missing.
Yeah.
When we talk about creating a web service like this, and saying that we are all done, we are doing similar to what I said before, that you spend 100% of your money on creating the kitchen. You're not creating the front part of your shop. Let's say I am your consumer. I am consumer of your web application, web services. I want to consume it. How do I see what web services are available? How do I see their performance costs associated with them? How can I maybe place an order? How can I call them? How can I see their response? Are you getting my point?
Yeah, the application interface is supposed to be at least ready for the clients.
Your things are fully, a kitchen is a fully functional thing.
Yeah.
But by just a kitchen, you cannot see, you need a place to advertise your products, right?
Yeah.
You need a place where people can go and see them, place the order. So in order to commoditize your web services as an API or as a microservices, you need a place. You need a whole bunch of package, a suite, which can let you do that. And that suite is what we call IBM API Connect. So IBM API Connect is not a platform which just allows you to develop a web service. Well, you have lots of different such platforms that allows you to develop the web service. Main benefit of IBM API Connect platform is that it lets you commoditize your web services or microservices as an API. And when they are commoditized as an API, that means you have the front face of your shop, which can be advertised over the web, maybe on Twitter, on social networking sites, and so on. People can click on the link, they can land to the page, the microsite, and then they can experiment with those APIs. And this is not a concept, this is not a new concept or bizarre concept that I'm introducing. You look at major technical players out there.
Sorry, I think there is an echo.
Yeah, so because people who are not speaking up, they are also, they have opened their mic too. Please, people who are not speaking up, please mute your mic. And whenever you need to speak up, you can unmute that. So what I'm bringing, the idea I'm bringing in here is that IBM API Connect lets you do that. Go around, so use today's time, at least half an hour, and search through the internet. You will see Google has their own set of APIs which you can access through some microsite, which may say developer.google.api. Box.com has their own set of APIs which you can access through developer.box.com. These are what? These are front face of their shop. When you access developer.google.com, you go to their shop. Then you will see their advertised products there. You can subscribe to them. You can experiment with them. And if you are satisfied, then you can order them. That's a paid subscription. But the idea, essential idea is that I have the basic ingredient with me, web services, and I want to commoditize it. To commoditize it, you need the right suit, right platform. And that right platform is IBM API Connect. Is that understood, guys? Did you get some visibility?
Yeah, I think it's clear.
Yeah, sure.
Cool, great. So we are now ready to look at the next slide. The next slide is an idea of engaging enterprise. Well, this is one that we understood in our demo session. So I'm just summarizing this. Will not spend much time on it, just summarizing it. The idea is that an enterprise must use its IT department in order to externalize its information system. By externalizing the information system, I mean the business that the entity is performing, it should chop down the business functionality into smaller pieces. Package these smaller pieces as API or set of APIs, and then expose it to the world. First user of these APIs are going to be app developers who have technical know-how as to how to consume these APIs. They create beautiful apps and then they distribute these apps to end customers. These apps could be run on a variety of different platforms and customers use these apps. Customers pass on the feedback to app developers, and app developers further pass on that feedback to the enterprise. The enterprise then rectifies their API, maybe end up creating newer versions of the API, and this evolution cycle keeps on going. The purple arrow shows the purple, hold on for a second. The purple arrow that you see here it shows the need of a platform that lets organization achieve this. Achieve what? Achieve the commoditization of their web service as an API. It lets app developer connect with these, it lets app developer connect with the enterprise in order to consume these API. This is the platform of which IBM API Connect is an example. You now know that in today's world, externalizing an API, externalizing the information system is how much important. Nobody wants to go to a store. Nobody wants to go to shop in order to do the business in a traditional way. Everybody demands a kind of app. Everybody demands a kind of a web front where they can order their stuff and they can get it delivered. So these APIs are of utmost importance in a practical world. Any question on this slide, guys?
Can we say that there is a mutual benefit between the enterprise and app developers in this regard?
Yes. You're right. There is a mutual benefit in this. Any other question, folks, on this slide? Are we good to proceed ahead in the next one? Okay, I'm assuming yes. So let's go to the next one then. Different types of API exposure. Well, APIs, in one way, they can be classified as a public, protected, and private APIs. Public APIs do not necessarily mean they are free. Public API means APIs which are accessible over the internet to the general public like me and you, right? An example of this public API is Google Maps API. Again, once again, I would say they do not necessarily mean to be free, but yeah, they're available to people like us. Protected APIs. These are APIs available only to designated business partners. For example, Toyota may have business partners that supply the motor parts to their engine, for their engine. So in order to get this supply, in order to place the order, and in order to place these orders, their business partners might have exposed the API that can only be consumed by customers like Toyota. This is B2B communication, and these APIs are protected APIs. Private API. Give me a second, guys. Give me a second. Okay, sorry for the pause. The third one is the private APIs. Private APIs are typically created so that different verticals of a company wants to intercommunicate with each other. These APIs are most likely not exposed over the internet. Why? Because we don't want any external customer or any business partner to consume these APIs. So they are exposed over private APIs, private IP addresses, and they are consumed in such a manner. So public, protected, and private. These are the three different kinds of API exposures that you will find in practice. Any question, guys, on this slide?
I think it's clear.
Okay, fine. The next one is the API management. What do we mean by an API management? What things we expect from a suite which can provide us the API and the management capability that I outlined in my previous discussion? Well, we want four things to be done, four core things to be done. First, we want help in creating the APIs. The platform must allow me set of features, developer tools that lets me create the APIs. That's one. Second, it lets me run these APIs. It provides me the runtime environment where I can run these APIs. Then it says manage the API. When I say manage the API, we should have the opportunity, or we should have tool sets to do the version control. We should have tools to do the deployment of the API. We should be able to deprecate the API. We should be able to enforce the retirement of the API. These are what we call manage the APIs. And then we must not forget about security. So the platform should allow me to do or to secure my APIs. These are the core expectations or core functionalities of any API management tool whatsoever. IBM API Connect, formerly known as IBM API Management, is one such tool that lets us do all these four tasks in beautiful manner. Well, if you go now and you will see the world, you will find that IBM API management is not only the one that lets you do that, but there are many. But when you deep dive into them, you will find that these tools, though they achieve these 4 functionalities, but they achieve in a different way. And those are the ways that you learn. Those are called product nuances. And these product nuances are something that you got to learn. When it comes to product nuances, you will see that one tool does it better than others. And that is the primary reason why you see in this Gartner image, there are some products which are considered as leaders. And there are some products which are considered as niche players. So this is the primary difference, the ease of use, the way in which they let you achieve this. These are the things that sets them apart. IBM is a great tool. IBM API Connect is a great tool that lets you do all these activities in simple, elegant, and cohesive manner. We will try to learn about IBM set of, our main focus in this course is going to be the IBM API management or IBM API Connect product suite. So from tomorrow onwards, we will be focusing on the IBM API Connect features and what you can do and what you cannot do with it. So here is the roadmap of a couple of days from today. Tomorrow, we're going to learn about IBM API Connect features in a theoretical sense. Day after tomorrow, we'll focus on very specific terminologies specific to IBM API Connect that is essential for you to know before you can practically learn them. Then we will focus on API lifecycle. We'll talk about API lifecycle, especially how it pertains to IBM API Connect. And we will talk about user roles in API Connect. After that, we will subscribe to Bluemix environment and we will kickstart learning APIs over there. We will build our first API in the Bluemix environment and you will have an opportunity to see how we do it in the API Connect environment. And then we will progress along. Theoretical sessions are just 2-3 sessions these days, these 2-3 initial sessions, and then we will learn on the Bluemix. We will understand a concept and then we will implement it there and then. So this is the road plan for, this is the roadmap of the first few sessions that are going to be there in upcoming days. Any question, guys, before we conclude today's discussion?
One last question, if you don't mind. What is the fundamental distinction or difference between API management and APIC?
That's just the version number. So API management and API Connect, both are same product. IBM API Connect product started with version 2. So all the way up to version 4, they used to call their product suite as IBM API Management. Starting from 4, all the way up to 3, they called it API Management. Starting from version 4, they renamed the same product and they call it now IBM API Connect. This is similar to saying that what is the difference between WebSphere message broker and IIB? It is the same product. But now, starting from version 9, they renamed message broker with what we call IIB. Isn't it?
All right.
Yeah.
If you dive deep, there are subtle differences, yes, because They are newer version of the product, so they are supposed to be more mature. They are supposed to have more functionality and features in them. A detailed comparison of different versions can be seen on IBM website. And the most prominent, the most visible, if you ever get a chance to deal with the different IBM API Connect versions, because I have been working it since it was version 3.0, the initial one. So you will see that there is a significant difference in the way you used to compose your APIs, you used to administer them from version 3 to version 5. But only if you get a chance to see those user interfaces, those older user interfaces, you will realize that.
So are we going to just see or focus on API management than the API?
Yes. No, we will focus on API management. Version 5 to be very precise.
So API management is a version from just less than 3, yeah? Version 1 to 3 is API management.
Version 1 to 3 is API management, yes. So we are focusing on API Connect. I'm sorry. We are going to focus on API Connect. And the latest version of it is version 5.0. So all our examples, all our exercises will be based on this version only, 5.0. Okay. Sorry, if I said it API management before, I'm sorry. Our focus is going to API Connect.
Yeah, I thought we are going to focus on the recent versions.
Yes, we'll focus on recent version only.
Okay.
Okay, so let's conclude our today's session here. Let's meet tomorrow at the same time and we'll keep it going.
So we're going to meet at the same time, 7:30 Eastern time?
Yes, at the same time. 5 a.m. India Standard Time.
Okay.
And the class is going to be Tuesday to Saturday. If you guys are in EST zone, then it is going to be, the classes are going to be your Monday evening time to Friday evening time. For me, it's Tuesday morning to Saturday morning.
Okay, I think today, for example, today we take this session on 7 Eastern time. So we will have the same schedule from Monday to Friday, and for Saturday.
Yes, you're right. So 7:30 Eastern time, you're gonna join this session, and all I'm saying is that 7:30 p.m. Monday, your Monday to your Friday.
Okay.
Make sense?
Yeah. I thought we're gonna have a session on weekend as well.
No, not on weekends. I'm really sorry.
Okay.
Okay, guys. See you tomorrow then. Good night. Bye-bye.
Good night. Bye.
Okay, bye. See you tomorrow.